with this, moving forward with the next session on context engineering for infrastructure, why the smartest model still cannot debug your cluster. To speak on this, we are delighted to welcome Shiv Pratap Singh, the CTO of NudgeBee. So he's a seasoned platform engineering leader with over 13 years of experience in building scalable high-performance infrastructure for startups and enterprises. Passionate about innovation, cloud-native technologies, and knowledge sharing, he helps organizations accelerate engineering excellence through modern platform practices. Please join me in welcoming Mr. Shiv Pratap Singh.
Context engineering, right? So today I was talking to a lot of people in terms of attendees, in terms of like who all are using AI for day-to-day operations, especially from infrastructure, SRE, troubleshooting perspective. Right? And I got to know a lot of people are using or they have built their own custom agents using MCPs or using AI bots which are publicly available to build or solve their day-to-day operation in terms of CI/CD pipeline filling, use MCPs to collect the data, identify the root cause, and etc. Right? So it's kind of interesting to know that a lot of people are building in-house solution for something similar using AI to basically solve day-to-day operations primarily from SRE and DevOps perspective, right? And this is more around like how to improve that experience, right? Like what all things which we have learned while building NudgeBee, which is a AI agentic solution or AI ops platform primarily for SRE and DevOps team. So this is more like a learning which we have learned over like last 1 year, 2 year kind of period, like challenges which we have faced while solving similar kind of problem and how we have basically approached it, right? So the title is basically context engineering because I'm assuming everyone already knows about like what exactly is prompt, how basically prompts work, where you use prompts, and then how context engineering basically fits into that, right? Now, context is something which your AI model basically sees, right? So when you basically send and build a complete prompt, send it, what is the data available to it is basically your context, right? So you may have heard like models normally ignore middle part, they'll focus on the first part, the last part, and what exactly the data which you are sending, right? What we have observed is, apart from prompt, the context or the data which you are sending to the model is the most important part to solve any kind of problem, right? Now, what should be that data in terms of, let's say, SRE team or DevOps team, which you should be sending to get most out of your LLM model, right? So, for example, it may happen you are using, let's say, best model, maybe Cloud Fable or Cloud Opus, etc., right? But you are not getting the result which you want, right? That okay, it is should be able to solve this, but why it is not working, right? So that might be a context problem rather than model not understanding your problem itself, right? Now think about a possible scenario, right? This is just overhyped version of the image, but think about it like there's an incident happened late at night, right? And you have built a AI resolution system around it, which should basically pick up the information, alert has happened, should give you like why that particular issue has happened, right? But you may find that, okay, that is not working correctly, right? Then you basically give it certain hint that, okay, this is not, my application setup is like this is the log which I have captured, right? You are doing, basically you are thinking on behalf of model, you are guiding it where it has to go and look into it, and then it is basically coming up with a solution, right? But for most of the part, that takes very long time, right? You are basically thinking, collecting the data, giving it to chat or your model, then it is basically processing it, giving you a next step, go and do this, right? Now you are again doing that part of the operation, right? What it basically lacks is your historical data. What kind of data it should basically look into to provide you the exact solution, right? Now, what we have identified is if you are solving generally any problem within an organization, but especially focused on infrastructure problem, you normally need a 5 kind of data points for a AI agent to basically help you in better. And this is basically correlates with like how we normally think about a problem. Right? First, for example, let's say if there is a error happens, right? You normally think about a general structure. Okay, if this is happening on a particular application, what exactly is upstream, what is the downstream of that application, right? If it is failing, then what are other applications which are failing, right? So your AI agent or model doesn't have this information by default, right? You have to tell it that, okay, this is how your setup is basically working. This is the application, these are the connected application. If your application is connecting to this database, then you need to tell it like, this is where my database is hosted, right? So that is more about the structure of your infrastructure, how everything is, right? Second is your historical data, right? Now if you ask any AI agent, tell me what happened to incident 1, 2, 3, 4. It doesn't really know what exactly incident 1, 2, 3, 4, right? You need to connect to it for, let's say, maybe a MCP, which is connecting to your conference, or maybe some GitHub repo where you are maintaining all of these incidents, what has happened to them, what kind of information it has, right? Now think about a scenario that incident again happened, right? Now if you are connected to conference, system can go look up to conference that, okay, last time when incident ABC happened, these are the 10 things which I have done, right? Now it has a context, historical context, what has previously happened, and it can basically perform similar operations again, right? Instead of you having to tell it again all those operations or provide that as a markdown file and then go and look into all the complete history, right? So that is more like a historical information. That is how most of the, let's say, SRE teams, engineers work, right? They go to GitHub history to look into what has previously happened, how my architecture looks like, where the deployments are, etc. So you have basically provided an overall historical context to your system for a better lookup, right? Then your operations, right? Everyone's infrastructure is very different. Even if you are using same technology, Kubernetes, Grafana, right? But still you will have your different setup than organization which is sitting next to you, right? Everyone basically uses the same technology in a very different way in terms of how they have evolved over the period of time, right? So then you need to tell system what exactly or how you are using these, right? So for example, a lot of organizations maintain a runbook that if this issue has happened, these are the 5 steps which I have to do, right? Or they maintain a naming convention or some kind of bibliography that, okay, someone is saying UI, then that means basically this is the application deployed in my Kubernetes cluster which someone outside say as UI, right? So now if someone created an incident in your system saying UI application is throwing 500 errors, right? Your agent can't automatically know what exactly the UI means, right? You need to tell it somewhere that this is the meaning of my naming convention, that if I'm saying UI, then that belongs to my Kubernetes cluster. Within that Kubernetes cluster, this is the application which is basically deployed and it is named as UI, right? If you are saying my payment service is not working, right? Your payment service not working is an end user symptom. They will say the payment is not working. But within your deployment model, that payment may belong to 10 different services, combining solving a payment service, right? So then you want to tell model that, okay, if someone is saying payment, then these are the 10 services which are basically solving that payment problem. Service 1 is doing this, service 2 is doing this, service 3 is doing this. And then it will know, okay, when someone is saying this, I have to look into these specific services rather than you telling it on the runtime that, okay, now go and look into these 10 different services, right? The fourth one is a real-time data, right? So all of this we are talking is more like a general organizational stuff, right? What is your deployment model? What is your historical data? What is your runbook which you have created and so on, right? Real-time data is more like system connecting real-time to your observability stack, your GitHub repos, etc., right? So the flow normally looks like, okay, it has identified where the application issue is happening. It has identified what is the runbook it has to execute, but now how it should execute, right? That is where your real-time connectivity comes in, right? Now you can do that through multiple ways. You can create an MCP server, connect to your Datadog, connect to your Grafana, etc. You can provide a API-based connectivity. There are multiple ways, right? But what you want is your LLM agent to basically perform those operations rather than you having to do that, right? So you don't want that LLM, and after understanding all of that, gave you a Loki query which you are executing into your Loki and then collecting the data, then again asking LLM, can you now process it, right? That basically increases your overall time window, right? What you want is a secured connectivity, basically backed by some kind of RBAC control. LLM executing that to your environment, collecting that data, and based on data, then reanalyzing and maybe changing the time windows up, down, etc. Right? Automatically collecting that information, analyzing it, and then give you a final response. Right? You don't want to be the middleman who is basically going, executing those queries and then giving again those responses. Right? But what I've observed is you need to be very careful with the real-time stuff. Right? So for example, I've observed people configuring their databases with LLM using MCP, but instead of giving a read-only access, they have given write kind of access, right? Now you are giving too much power to LLM, right? What if it decided while doing a troubleshooting, it decided that, okay, to troubleshoot this, I need to drop this particular constraint from database, right? And it will go ahead and do that, right? Without you having to basically, without you approving it, or maybe you are running it in like more like a dangerous mode where it has basically all the privileges and not asking you for anything, right? So you need to be careful with what kind of privileges you are giving, but the ideal way is you should start with a read-only user, give it MCP based access, CLI based access, whatever it is, and let LLM do its work. The fifth part is, and which is most important from most of the troubleshooting part, right? 90% of the troubleshooting is basically what was deployed last time, go ahead and revert it, right? Or this has deployed, so you know like, okay, these are the 5 deployments which has happened, and they may have caused the issue because the issue was not happening before that, right? So that is where the most of like 80%, 90% of the issues start occurring, right? So what you want is understanding LLM, understanding how it can connect with your deployment system, maybe GitHub Action, maybe you are using Jenkins, whatever it is, right? So it basically able to connect to it. Then identify what was the last deployment happened, it connecting to your GitHub, and then identifying what was the last code which has changed, and telling you better picture around it, what may have caused the overall problem, right? So first 3 are more like a general organizational structure in terms of how you have set up your environment, and other 2 are basically LLM doing a querying and doing a further troubleshooting to identify the actual root cause of your problem. Right. Now, what we have also identified, if you have a better context quality, right, the information which you are feeding to LLM, right, the better it has, the more accuracy you get, right. For example, one of the common use cases which we find while doing a customer environment deployment and all, let's say we did a very like, they just started it, right? They haven't provided any kind of context, any kind of information, and someone created an incident report that I am facing issue on my UI. And that is how most of the incident looks like, the first liner, right? And let's say there is no one yet involved. Your agent got this one liner that, okay, I am facing slowness on my web application. Now it doesn't really know anything about it, right? It doesn't, even if you give it all the context, right? It still will face a problem. What exactly this particular word mean? Like you have basically 10,000 API calls coming in, where it should basically go and look into what exactly that slowness means, right? So providing a better incident description normally helps a lot in terms of if you have like let's say some kind of incident form etc. where user can provide you information in terms of that, okay, this is the page which is slow, right, or this is the API which is slow, right? So then it provides some more context to agents that where they have to look into. Same goes with the human as well. But let's say if you have an automated system setups, right, they normally have a better visibility in terms of, let's say when you define an automated system, you already define an alert rule, alert criteria, labels which will get generated, etc. Right? So when those get generated, systems normally have a better understanding. Okay, these are the labels belong to this particular application. This is the alert rule, so I can go ahead and look into alert rule. What was the normal condition versus what is the current condition when user is facing, right? So that basically helps a lot in terms of troubleshooting a particular issue through AI agents and all, right? This is more like something which I covered in previous in terms of when we say what is structure, it means basically system telling the dependencies about different applications, right? What is your service topology, which are the services deployed, how they are connected with rest of the application. If one fails, do we know like other application will fail or not, what kind of API connectivity happens, etc. Right? So more about system understanding your service technology, topology. Most of the users already know, unless like you have a very big organization. Normally, if you are a small organization, DevOps teams, dev teams know like what their dependencies are. But if you are at a very large scale, right, then to understand dependency, you need a 20-member team, war room to basically tell like, is it going to impact your application? Is it going to impact this application, etc. So that is where you see like very large scale war rooms being set up, right? Everyone is getting pinged that, okay, come into the war room, is it like impacting you, is it your use case, is it failing there, etc. Right? Because you don't really know if the issue is happening, is it basically impacting the other team or not, or whether that is caused by other team. Right? So some kind of service dependencies normally help. On the operational context or its historical data, right? So normally the way we solve it, but everyone can solve it differently. So for example, we basically try to connect with your existing documentation system. That can be Confluence, ServiceNow, it can be something which you can create within the platform, either using markdown files. If you have built your own agent, then you can provide markdown to it directly, connect to it, NCP, etc. But the goal is to basically provide a historical data. It can be your, let's say, Jira ticket, which has an incident information, how people had solved it previously. Like it can be your Confluence documentation which contains architecture, etc. Right? Then similarly, more context in terms of what the naming conventions are, how everyone basically talk to it, etc. Right? So we basically talk about real-time context in terms of like observability stack, CI/CD, code. Internet tech stack is another interesting problem. Lot of time. If your agent is connecting to different systems, they can't just go ahead and then execute a query, let's say, right? Because those are not exposed, they are maybe different VPCs, etc. Right? So the one way to solve it is basically create a MCP around it, because MCPs provide a better reference in terms of what different fields means, what is the documentation, what can be the prompt use. So you can basically wrap around your internal API call, expose them as MCP, and then connect with your agent so that it knows like how those internal stacks can be used and where they can be used. Right? So this is again difference. So we started with this particular guy, right? He faced the problem. There was no way to basically solve it. Now let's say if you connect all of these different systems, right? You basically see alert got fired. You have loaded a context dynamically. Your context can be the historical data which a system has basically solved. For example, it can be, let's say, alert has an incident name. It looked up your Confluence to identify that incident name and then loaded up a runbook like how that should be solved, right? Then it also checked its previous memory. Right? So memory is something which you need to potentially build, right? For example, you can store every incident which you are solving, right? You can have another LLM agent going through the incident resolution step, extracting a certain key element around it. Like, okay, if this incident is happening, then these are the steps which I had followed, right? So you have basically a side agent which is looking into every single step which you have solved, creating a memory out of it, storing it into a RAG kind of system or something similar. So when you are loading a context, you also load a memory by looking up as a semantic search that, okay, is this a problem which is solved by the agent previously? Or when you are doing just a conversation with it, you can have a parallel system that if conversations are very long, then go ahead and review the conversation and identify critical points from that so that it can be loaded again when the user is asking a similar question, right? So, okay, there's a memory match which happened, right? Now with the context and memory match, I have identified that, okay, this issue has previously been reported, this was the runbook, this is how I had solved. So now I can simply go and look up a root cause, right? Versus me without all of this information, first looking into your infrastructure to do a key match to identify which service was this, then going through all the logs and then identifying which log I have to look into, looking into traces, stack, etc. Right? But if I already have a context and historical references, I can go ahead, identify the root cause, then I can go into next resolution step because I already know like how it had been solved in the previous past or how the runbooks are basically written around it, right? Okay, so that is more around context engineering in terms of how you probably try to solve an incident in terms of infrastructure and application, right? I'll be skipping these. Generally how that looks like in practice, you receive an incident, right? There's an issue happened, any system, I mean it doesn't have to be a UI, it's just a UI, something which I'm showing because it's from NudgeBee, right? So it basically generates an incident, received the incident, it is connected with your all the conference and all, collected the data and generate your event summary that okay, this is where the root cause has happened, right? There's no human involved in this system, right? It has automatically generated a complete root cause analysis. Now when you involve a user, that is basically to review this root cause analysis, identify if it is a correct. If it is a correct, then basically perform the next step, which is merging a code because it is proposing a code fix, right? If it is not correct, right, then you want to teach the system, right? You basically go to the next step, tell it that okay, you have performed this step, next time onwards basically perform these additional steps, right? That becomes your memory extraction part, right? Now you have learned from user that okay, next time onwards I have to do these additional steps from solving a problem rather than you having to do this activity every time when system is basically trying to do that, right? So that is generally how overall setup or how a troubleshooting within infrastructure tool or something like that looks like, right? So what I would like you to know from this talk is, one is context engineering is more important than your model selection. And then one point on that, so just trying to think, okay. So one point is, model selection is also critical in terms of you don't want to use a same model for every single thing, right? So you don't want to use, let's say, Opus, Fable, Opus, like Claude, Opus or Fable for every single thing which you are doing, right? You want to also manage the cost, right? You don't want to come into a situation where you are spending a $35 per incident analysis, right? Because you need to analyze a log, you need to analyze matrix, you need to load some kind of documentation. It's a very long cycle, right? You don't want to come up with a cost like one incident is basically $50, one incident analysis, right? It doesn't matches with the, let's say, your human cost, right? The model cost or overall cost should be less than how much a human is going to spend, then only it makes financial sense, right? Irrespective of how the technology is, right? So what you want to control is how the cost is basically going to play out, right? So even if you are doing a model selection, you need to basically have 3-4 variation around model that okay, if I'm going to do the planning, I will use the most sophisticated model in the world, right? But if I'm going to execute steps around those plans, then I will use maybe something average kind of model, which doesn't have to think much, but it's just generating a code, executing it and all, right? But if I'm generating a final incident report, I'm generating a summary around different steps, I'm analyzing what had previously done, I would probably use a lower end model called summary and something, right? So you want to distribute your model selection across all of these areas rather than using a best model for all of these tasks, right? Otherwise cost won't work out for you, right? So that's a more on like how you want to basically do a model selection. Don't do like best model for every single thing, right? Yeah, so then another one is like you don't want to ingest every single thing into your rack system and do a semantic search and all that. That doesn't work financially and it won't work out for search and other aspects, but that becomes very costly, right? So what you want is your agent to do a live query around wherever it is possible, right? So for example, documentation, you don't really need a live query. But for log matrices, etc., you probably need a live query to basically go execute that query, collect the data and so on, right? So don't basically push every single thing to that. Doesn't work out at a scale, right? So that's a passive ingestion and security purposes. Then other part is building all of that is complicated, so that is NudgeBee self-promotion. So You can basically use NudgeBee's open source version. It is basically available on GitHub for all the things which we do, how we do, etc. We are open for contribution. You can contribute it. You can basically use it at your own environment. There's an integration if you want to do, you can do that. If you want to contribute back to community, you can do that. Right? So yeah, that is from the talk perspective. Any question or anything if you have faced challenge, etc. Okay. Any question? Yes, please.
Customer or multiple customer actually. So that's the first step, and the next one is like, hey, what are the teams we need to call? I mean, to page for this incident. Once you understand the priority.
So as to the first question in terms of the impact analysis, second question.
What teams to page generally, like what happens is when we have this agents looking into it, many times they get confused. They page the wrong teams and all. That's where like.
Understood, right? So from an impact perspective, so impact analysis normally is a organizational stuff, right? Your organization may have a different way to calculate impact. So for example, there is a generic way. If there is a application which is deployed connecting to 10 different applications from a service graph perspective has a more impact than anything which is isolated, right? Or you can even build a generic knowledge as well. For example, let's say if I'm looking into only Kubernetes cluster, right? I can exclude any kind of observability system. They are not directly impacting your application, but anything which is connected with your load balancer, right? That has a direct impact if that application is down, or if there's a database running within your Kubernetes cluster, that has a more impact, right? So if you want to build a generic system, right? Let's say when we bootstrap NudgeBee, right? We basically look into your topology and decide how the application criticalities vary based on these clusters, right? Now, as an end user, you have an option to override this. You may say that, okay, based on this application is critical because of these reasons, right? Now, same you can think about anything which you are building, right? You can think or decide criticality based on like overall network topology, but you can also give instruction to the system that, okay, these are the more critical systems, and when you are analyzing criticality, whether that is a critical or not, right? You can basically execute this query to identify a overall customer who are going to impact because of this reason, and then adjust the severity, right? So if I have to do something, I will probably build two separate agents. One is an impact analysis agent, which will basically get the data, right? Execute your, let's say, template the way you decide a criticality, then calculate a criticality score, assign it to a particular issue that, okay, it's a medium, it's a low, etc., right? Once the criticality is decided, I will go into the next step that, okay, if the criticality, let's say source system is saying it's a high, right? But based on your criticality analysis, it's low. I would probably drop the incident itself, or maybe move it to review, like, so that someone can verify if this is the analysis is correct or not, right? Then if it is critical, then I will move it to next step and do a automated analysis, because you can't just simply do an analysis of every single alert, right? Because that will be too costly to do, right? So you basically try to treat it like, if it is a critical, do an incident analysis immediately. If it is not critical, medium or low kind of thing, maybe park it for the later kind of thing, right? Same with your team as well. For example, normally the way we decide a team is basically based on a service. If this is a service, who is the team owner, or if this is a service, it gets deployed, then where that connectivity is, like who was the last user who has deployed it, right? So if you are basically sending an alert, you can basically look into who had last committed or who is the service owner and then ping it. So it's based on a per service basis rather than looking into overall system. Anyone else? Yes, please. Can you please repeat?
Yeah. Am I audible?
Yeah, yes.
So I was saying, question around the design part. As you said, like you don't want to make RAG calls all the time because, and also the context, your context will be very heavy because of the source code pass logs and other details. So how are you ensuring that?
Okay, so how the design normally works,
Yeah.
right? So the way we try to do it, there's a, let's say, agent for different section. So instead of, we normally work in a parent-child hierarchy. There's a planner agent which creates a plan or analyzes a data from sub-agent and delegates to sub-agent, right? So instead of we analyzing log in the same context, we basically delegate to a log agent, give it a context in terms of this is the user query, this is the history around it. Log agent's responsibility is to collect your observability system, collect all the logs, analyze it based on what planner has sent, summarize it, and then return to planner. So planner's context window is not populated with all the details around your log, etc. Right? It has called a log agent, got what it needed. Now it will basically go into next step, right? And you don't lose the data. You want to basically store that log into some kind of storage. Okay, this is what the log I had got. I have stored it to my file system for a workspace kind of thing. So that if you want to reference it again, you already have that stored rather than doing a requery, right? So normally we try to delegate into a parent-child kind of context, right? If anything which is going to take more memory, for example, traces is like very huge most of the time, right? So we want to delegate to a separate agent, which whole responsibility is to query the trace, analyze the critical pieces, and return it back to planner so that planner can take a decision on top of it.
But then how, like suppose crash to back off error, right? It can have, it will not happen in isolation or for one particular reason. It can happen because of some issues in source code as well. Then how are you managing that for this error and to have an accurate resolution? You're ensuring that the one which does not need AI assistance can be solved there itself, and the one where actual AI assistant is needed, there you send the context heavy.
Okay, so in our case, we don't really decide in terms of what can be solved by AI agent and not, right? So there is a criticality here. If system thinks it is a high-end critical, then it always goes and delegated to AI agent to do a root cause analysis. If it is a medium-low priority, then don't touch it unless or until user comes to that particular screen. Then you trigger an analysis in the background, right? What we also try to do is don't move everything to AI agent, right? There is a pre-step which looks into your label, collects the static data. So for example, if I look into your label and I know this is the pod name, this is a namespace name, I will just simply go and do a local query and collect that particular data, right? I don't really need to rely on AI agent to basically do that, right? I can just do a plus minus generate the data and then this is where the data looks like, right? So you collect this static data first, then go to AI agent that, okay, this is what I have already collected. Is it providing a root cause? If it is not providing a root cause, then you go into agentic loop to basically collect all other relevant data and then analyze it. Right? So you probably try to avoid everything agent, right? You need to do a, like, what is static versus what is dynamic. Okay, thank you. Thanks a lot.
Alright, thank you so much. Now I would like to call upon stage Satish MR, DevOps leader from Apna to facilitate sir.